Good day. Today we're going to focus on binomial exam questions. Basically, we're going to prove binomial identities. I have these questions which were asked in the exam. The first one was prove the binomial identity 8 combination 3 plus 8 combination 2 is equal to 9 combination 3. And the question is asking us to apply the binomial identity and show all steps clearly. Then question 2 is saying prove that n combination r plus n combination r minus 1 is equal to n plus 1 combination r. Use the binomial formula and justify each step. So we are going to prove these identities. So how can you prove the binomial identities? This is what we are yet to talk about. Let's start with the first question. So it is 8 combination 3 plus 8 combination 2 is equal to 9 combination 3. Okay. So the question is 8 combination 3 plus 8 combination 2 is equal to 9 combination 3. So we want to prove that this is basically equal to that. So how can we prove this? So let's take the left hand side, which seems to be complicated, so that we'll get to the right hand side. So let's start with 8 combination 3 plus 8 combination 2. We are taking the left hand side, so this will be equal to 8 combination 3. We use the formula n combination r is equal to n factorial over n minus r factorial r factorial. So when we have 8 combination 3, we are saying our n is 8 and our r is equal to 3. So we apply this formula. So this will be equal to, where there is n, we are going to say 8 factorial over n minus r, which is 8 minus 3 factorial, then 3 factorial, which is r factorial. Then we come to 8 combination 2. So this will be equal to plus 8 combination 2. We are saying it is 8 factorial over 8 minus 2 factorial, then 2 factorial. Now let me get rid of this. Alright, so what we have, this will be equal to 8 factorial over 8 minus 3 is 5. So I'm going to say 5 factorial, then multiplied by 3 factorial plus 8 factorial over 8 minus 2, that is 6, so 6 factorial, then 2 factorial. At this point now, we are going to find the common denominator. This is addition, so we find the common denominator. So what will be our common denominator? We are going to take the bigger number, because bigger numbers, a smaller number can go into a bigger number. So between 5 factorial and 6 factorial, which one is bigger, it is simply 6 factorial. So 6 factorial, we take it on the denominator. Then between 3 factorial and 2 factorial, the bigger one is 3 factorial, so we take 3 factorial. So this is our common denominator. Now what we are going to do, we're going to divide 5 factorial into 6 factorial. You see, 6 factorial means we are dividing. So 6 factorial divided by 5 factorial. So 6 factorial simply means 6 times 5 factorial. That's the meaning. So it is 6 times 5 factorial. Now divide by 5 factorial. 5 factorial and 5 factorial cancel out. So we just remain with 6. So this is the initiative we're going to apply here. So I'm going to say this is equal to just 6. Then multiplied by, of course, we multiply by the numerator, because 3 factorial and 3 factorial will cancel out. So multiply by 8 factorial, then plus 6 factorial into 6 factorial, that is just 1. So these two will cancel out. Then 2 factorial into 3 factorial. So we are saying 3 factorial divided by 2 factorial. So 3 factorial is simply 3 times 2 factorial over 2 factorial. So 2 factorial and 2 factorial cancel out, and we're just going to remain with a 3. So that is what we're going to say. 3 multiplied by 8 factorial, the numerator. So at this point, we can now factorize. We can factorize 8 factorial on the numerator. Then in the brackets, we are going to remain with 6 plus 3. Then on the denominator, it is the same thing, 6 factorial, 3 factorial. Okay, so this will be equal to, so we have 8 factorial, 6 multiplied by, 6 plus 3, that is a 9. So we have 8 factorial multiplied by a 9 over 6 factorial, 3 factorial. So this will be equal to, when you have 9 multiplied by 8 factorial, this is just 9 factorial, because 9 factorial is 9 multiplied by 8 multiplied by 7 multiplied by 6 multiplied by 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. But we can just end on 8. So this is same as 9 multiplied by 8 factorial. Okay, so that is the meaning there. So over 6 factorial, 3 factorial. You see, 9 factorial divided by 6 factorial, 3 factorial. This is just same as saying 9 factorial over 6 factorial is same as saying 9 minus 3 factorial, then 3 factorial. You see that? Then we can apply the formula. We said n combination R is equal to n factorial over n minus R factorial. So we can see that if we compare this side, this is what we have there. Okay, so what does it imply? So our n is equal to 9. So this is n is equal to 9. So we're going to say 9, n is equal to 9. Then what is our R? Our R is this 3. So our R is a 3. So what does it imply? So this implies that we can now put in this in the binomial way. We can say n combination r. So this will be equal to what? This will be equal to 9 combination 3. So 9 combination 3 is what we are getting on the left hand side. And we can see that from our question, on the right hand side we had 9 combination 3, and which we've proved. So this is equal to the right hand side. So hence proved. So we've proved this one. Let's look at the second question. It is n combination r plus n combination r minus 1, then n plus 1 combination r. So let's do the second one. So what we have is n combination r plus n, then r minus 1. This is n combination r minus 1 is equal to n plus 1, so which is n plus 1 combination r. So this is what we want to prove. So the complicated side is the left hand side. So I'm going to say, taking the left hand side, so n combination r, as we did in the previous question, so it is n factorial over n minus r factorial, then plus n combination r minus 1. This is same as saying n factorial over n minus, we are subtracting r minus 1, but this must be in brackets like that, factorial, then r factorial, which is again n r minus 1 factorial. So this is what it means. So we want to get to this point, the right hand side. So what we are going to do at this point now, we are going to say n factorial over n minus r factorial plus n factorial over, you see, n minus r minus 1 in parentheses factorial. This is simply saying, or it implies that we distribute the negative sign. So it will be n negative multiplied by r, so negative r, negative multiplied by negative there is positive, so it will be plus 1, then factorial, then we have r minus 1 in parentheses factorial. Okay, at this step we can now do this. We can find the common denominator. So the common denominator should be the bigger one. So we can have the bigger one between n minus r and n minus r plus 1 factorial. It is simply n minus 1 plus minus r plus 1 factorial. So that is the bigger one. So the bigger value is this one, factorial. Then between r and r minus 1 factorial, the bigger one is just r. Okay, so we're going now to say n minus r factorial into this. You see, r factorial and r factorial will cancel out. So what we are simply saying is n minus r into n minus r plus 1. So as we did in the previous question, this is the same as just saying Rn minus R plus 1. So it's just this same value there without a factorial. Okay, that's what we did in the previous question. So it is just n minus R plus 1, like that. Then we are multiplying this by n factorial, then plus, we come to this side, n minus 1 plus n minus r plus 1 factorial into this n minus 1 plus r. This will cancel out. So what we are dividing is simply r minus 1 into r factorial, which is just r. Okay, we just get this value without this this variable, I mean, without the factorial. So that's the meaning in simpler terms. So what are we going to have? So here we've said it is just r, but r was multiplying, it was multiplying n factorial. Okay, so what we are going to have at this point, we can factor out r factorial. So we can say, I mean n factorial, we factor out. Then in brackets we're going to remain with n minus r plus 1, then with this r plus r, then over on the denominator, this is what we are going to have, the same one, n minus r plus 1 factorial r factorial. Then what we are going to do, we see that n r minus r negative r plus r is just 0. So what we are going to have is r factorial, open bracket, r plus 1, I mean n factorial, open bracket, n plus 1, over what we have on the denominator is n minus r plus 1 factorial r factorial. So what we have, when we have n factorial multiplied by n plus 1 factorial, this is just same as saying we have a situation like 9 factorial maybe multiplied by 10. 9 factorial multiplied by 10, right? Or let me make it similar. We say 9 factorial multiplied by 9 plus 1, which is just 10. So this is the same as saying 9 factorial multiplied by 10, and 9 factorial multiplied by 10 is just a 10 factorial. So we apply the same thing here. So this is just n plus 1 factorial. Then on the denominator it will be over, when we have n minus r plus 1 factorial, so that is what we have. So n minus r plus 1, or let me write it say this, n plus 1 minus r factorial r factorial. So this is simply saying, when we compare to n combination r, which is equal to n factorial over n minus r factorial r factorial, we discover that our n in this case is n plus 1. So we substitute there. So this is same as saying n plus 1 combination. When we have n, our r in this case, our r in this case, it will simply be this one, this r, okay? It is the same r, that is the r we have. So our r, it's still r there. So this is the combination, and we can check from our previous from our question rather. It was to prove that n combination r plus n combination r minus 1 is equal to n plus 1 combination r, of which we've proved. So this is how we can prove binomial identities. Thank you for watching.